So, Chapter 7 is all about logarithmic functions, but you have to do exponential to get you to logarithmic, okay? So, 7.1 is going to be exponential growth and decay graphs and functions, and then we're going to have 2 word problems at the end. Exponential growth and decay is something that is covered in Algebra 1. So though it was 2 years ago, y'all might not remember it, you did cover it. And this is very easy, okay? Your parent function for exponential functions is really y equals b to the x. That a shouldn't be included. This b could be any number. So typically a parent function is the same no matter what. So the linear parent function is y equals x, quadratic is y equals x squared, cubic y equals x cubed, no matter what. Okay? With exponential and logs, it's a little bit different. The parent function just means you have any number base that's a real positive number raised to an x power. So the x being in the exponent is what makes it exponential. Okay? So anything other than that is considered a transformation. So if I'm looking at f of x equals a times b to the x minus h power plus k, you can kind of compare that to if I had f of x equals a times the x minus h squared plus k. So think about that quadratic form that we would look at. That's considered vertex form, but that's what would tell us our transformations. Okay, so if you remember, the a here would tell me if I had a number in front of the parentheses, it would indicate a stretch or a shrink, right? So the a that's going to be multiplied by your b, your base, that's going to be stretch or a shrink. The h that happened to your x would tell me it shifts left or right. Y'all remember this? So the same thing happens here. If it's happening to x, that h is telling you left or right. Okay? The plus k would tell me it shifts up and down, so this plus k also tells me it shifts up and down. So the same type of transformations. So I feel like y'all are at the point this year, I could give you any function and you should be able to identify your transformation. Okay? Now, what's different with exponential is you have a growth or a decay factor. Okay, so how do I know which one is which? If your base that's being raised to the exponent is greater than 1, it's an exponential growth. Okay, if it is a fraction less than 1, so we're not considering negatives because a negative just tells me it's a reflection. Okay, so if the value is a fraction less than 1, then it's a decay. All right, so if you think back to Chapter 8, what y'all just tested over, you had horizontal and vertical asymptotes, right? So the mathematical definition is something you'll get into later on in y'all's math courses, but the general definition that we look at is an asymptote is what your graph approaches but never crosses. So exponential functions also have asymptotes, okay? So they're going to have a horizontal asymptote, and whatever your k value is that's added or subtracted at the very end is what your asymptote is going to be, okay? So visually, you don't have to graph this, just look at the screen. If I were to graph 2 to the x power, okay, that's a parent function. That's what it would look like. Okay, so see how it starts to level out around the x-axis? That's my asymptote. It doesn't go down past the x-axis. So y equals 0 would be my horizontal asymptote. Okay, but if I were to graph 2 to the x power, why is that counting? There we go. And say plus 3. Okay, that plus 3 tells me it's going to go where? Up 3. Okay, so I shifted my whole entire graph up 3, which also makes my asymptote shift up 3. Okay, so that's why your k value is going to be your horizontal asymptote. Okay, so I just wanted y'all to visually see that because I didn't put an example right there in the notes. We're going to have to do domain and range. Okay, so your domain for exponential is all real numbers. Okay, so you can do the set builder, or I always do interval notation. I think it's easier. I don't care which one you do. And then your range depends on where your graph falls according to your horizontal asymptote. Okay, so we're going to look at that. You've got the table of examples. I'm not going to go over that. If you want to look through that on your own time, you can. You should be able to identify transformations. Okay, but that's there for your reference if you need it. Okay, so you're going to have a section where you have to identify if it's an exponential growth or decay, what the asymptote is, and what the transformations are without graphing. Okay, so you're going to have it on your worksheet, you're going to have it on your test. So if I'm looking, I said that your horizontal asymptote is y equals k. Okay, and then we said that you've got y equals a times b to the x power minus h and then plus k. So if you need to compare where k is, it's always at the end. Okay, so if I'm looking, first I need to identify, is it a growth or a decay? So I'm going to look at my base that's being raised to the exponent. It's 3/4, so that's going to make it an exponential decay. Okay, and then my horizontal asymptote is going to be y equals 5. So that k is 5, that's going to be my asymptote. Alright, then I need to look at my transformations. I always go from left to right. So this negative tells me I'm going to have a reflection, but which axis is it going to reflect over? So would this happen, if I was building a table, would this happen to x or y? So x is up here. Is it on my x? No, so it's happening to my y. So if I have a graph, and I have a y up here, and I make that y negative, that means it comes down here, right? Because these are my negative y values. What axis did it flip over? Okay, so it reflects over the x-axis. Then the 2 tells me it's a vertical stretch by a factor of 2. The x plus 4, remember, whatever happens to x is the opposite of. X is a liar. So that really shifts where? If it's a plus 4, it's the opposite, and it's going left 4 units. And then the plus 5 tells me it's shifting up 5 units. Okay, are we good with that? So here I've got 6 times 2 to the x minus 1. My base is 2. Is that going to be a growth or a decay? A growth. Okay, my horizontal asymptote is based on what's added or subtracted at the very end. Do I have anything added or subtracted at the end? No. So that would be y equals 0. Okay, now this 6 in the front tells me it's a vertical stretch or shrink. Stretch by a factor of 6. And then the x minus 1 tells me it shifts where? Opposite of what it looks like, so right 1 unit. And that's it. Okay, next example, I've got 2/5 times 2 raised to the x plus 3 minus 4. My base is 2 again, so that is another growth. And my horizontal asymptote is y equals -4. And the 2/5 tells me I have a vertical compression or shrink by my 2/5. And then it shifts left 3 units and down 4 units. Okay, y'all remember y'all's transformations? Okay. So when we're graphing, we're going to do all that, but we're going to do our tables also. Okay. So if I have f of x equals 2 to the x power, okay, is that a growth or a decay? It's a growth. What's my horizontal asymptote? Y equals 0, because there's nothing added or subtracted. This is a parent function. There's no transformations. So when I build my table, I'm going to do -2, -1, 0, 1, and 2 for my x values. Okay, I want to span a decent amount to include negatives and positives for my x's. Okay, so I can build it two ways. I can take my base 2 and raise it to the -2 power. I get 1/4, which as a decimal you can write 1/4, or as a decimal that is 0.25. Okay, 2 to the -1 power is 1/2, which is 0.5. 2 to the 0 power, anything to the 0 power is 1. 2 to the first is 2. 2 squared is 4. So it's as easy as doing that on a basic calculator. So you don't need the graphing calculator. Okay? But if you don't want to do that and you have access to the graphing calculator, all you have to do, type it in your calculator, Control-T, copy down the points. Okay, I don't care which one you do. Just make sure you do one of them. Okay? But that's going to be for the parent function. Okay? If we have transformations, then we're going to do a transformation table like we always do. So here, I'm going to graph my horizontal asymptote. So y equals 0 is going to be my dashed horizontal line. If you're doing it in pencil, make sure I can see that you have the asymptote there. And then you're going to plot your points. Bless you. Could I have included more points? Sure. But your bare minimum, I want you going from -2 to 2. Okay? So now I need to look at domain and range since I don't have transformations. My domain, do I have a boundary on the left or the right? So a boundary would be a vertical asymptote. I don't have a vertical asymptote, so that's my all real numbers, -infinity to +infinity. But my range, I don't go any lower than what point? 0. That's my asymptote. Everything is above that. So I'm going from 0 to +infinity because I'm going upward. Okay, if I did set builder, then it would be y is greater than 0, but it's not equal to because it never actually hits that line. Okay, we good with that? All right, so if I have f of x equals 1/2 times 4 to the x power, is that a growth or a decay? It's a growth because my base is 4. What's my horizontal asymptote going to be? Y equals 0 again. So I'm going to do my parent function. So how do I know what my parent function is? Whatever is being raised to the x power is your parent function. Okay? So y equals 4 to the x is going to be my first table. So I'm going to do -2, -1, 0, 1, 2. Okay, you can type it in your calculator or just type it in your, you can type it in the scientific or Inspire. Okay, so if I have 4 to the -2 power, that's 1/16, which is, let's say, round that to 0.1. 4 to the -1 power is going to give me 1/4, which is 0.25. 4 to the 0 is 1. 4 to the first power is 4, and 4 squared is 16. Okay? That's not what I'm graphing, right? I have a transformation here. So I'm going to build my transformation table. So we're going to look at our x. Is anything happening to my x? No, so they stay the same. Your y, what's happening to y? So it should be 1/2 y. Y'all remember doing this? Hopefully. Okay. So then I'm going to take these y values, multiply it by 1/2. Okay, so 0.1 times 0.5 is going to give me 0.05. 0.25 times 0.5, because that's 1/2. We're going to round that to 0.13. 1 times 1/2 is just my 1/2, 0.5. 4 times 1/2, half of 4 is 2. And half of 16 is 8. Okay? If I would have graphed that, and I would have looked, those are my points. Okay? So again, I don't care which way you do it. But when I say get from the points, you can double check yourself with this, but I expect to see these two tables. Okay? So personally, I would say get your parent function if you want from the Inspire, but you're still going to have to manipulate it this way. I'm still going to be checking, do you know how to build this table? Okay? So you can check yourself the way that I just did. Plug in your full function, make sure the table is correct. But I expect to see both of these. Okay? So my horizontal asymptote, y equals 0. So both of those are increasing from left to right. If you notice that, they look pretty much the same. That's because with a growth, from left to right, you will increase exponentially. So a decay from left to right will be the opposite. It will start really high and then start to level out on the right end. So a growth increases left to right, a decay decreases from left to right. Okay, so then our transformations here, the only transformation I have is a vertical shrink because of the 1/2. So a vertical shrink by a factor of 1/2. My domain stays negative infinity to positive infinity. And my range is going to be what? 0 to positive infinity. So whatever your horizontal asymptote is the number that goes in your range. Okay? Because I'm not going any lower than that asymptote. So that's why I say whatever your asymptote is the number that goes in your range. It just depends, is my graph above or below? So if my graph were below, then you go from negative infinity, and that asymptote would then be a maximum boundary, so a top boundary. Yes.
How do you determine the domain?
The domain, you don't have a vertical asymptote, so it's always going to go forever to the left, negative infinity, forever to the right, positive infinity.
So if I also have, is it always going to be negative infinity, positive infinity?
For exponential.
Okay.
Okay, so this one we're going to do pretty quickly. What's my parent function? Well, before we do that, is it growth or decay? Decay, because my base is 1/2. What's my horizontal asymptote? Y equals -2. So my parent function is whatever's being raised to the x, and it's only x. So my parent function would be 1/2 to the x power. So if you want to just type that in, my points would be -2, 4, -1, 2, 0, 1, 1.5, and 2, 0.25. Okay, then my transformation table, what's happening to my x realistically? It's x plus 1 in my function, but in my table, x minus 1. So remember, it's the opposite of. When you have your x's, the translations are opposite of. But if I had a negative on that x, the negative stays. Okay, so it's only the plus and minus that gets flipped. Okay, so then my y, what do I put in my y table? 3y minus 2. Alright, so my x is -2 minus 1 is -3. -1 minus 1 is -2. 0 minus 1 is -1. 1 minus 1 is 0. 2 minus 1 is 1. Okay, then your 3y minus 2. 4 times 3 is 12, minus 2 is 10. 2 times 3 is 6, minus 2 is 4. 1 times 3 is 3, minus 2 is 1. Okay, 3 times 0.5. So half of 3 is 1.5, minus 2 is a -0.5. Okay, a fourth of 3 is 3/4, which is 0.75. Minus 2 is a -1.25. Could you use your calculator? Yes. Okay. So I'm going to draw my horizontal asymptote at -2. So since it's a decay, it's decreasing from left to right, so that's why it looks like it flips sides. But that's not a reflection. It's just the way a decay is graphed. So my transformations, that 3 tells me I have a vertical stretch by a factor of 3. That x plus 1 was really x minus 1, so I shift left 1 unit. And down 2 units. My domain is all real numbers, -infinity to +infinity. Now my range is what? -2 to +infinity. Okay? So if my graph, say here's my asymptote, if my graph looked like this, that means I would have had a reflection. My range here, say this is y equals 4. It would not be 4 to +infinity because +infinity is going up, but my graph is going down. And it is not 4 to negative infinity because range technically is from bottom to top. So you're going from negative infinity all the way up to 4, but you don't go past 4. Okay, so that isn't an example in the notes, so I want to make sure you'll understand what that range would look like. Okay? Alright, questions on the graph. Okay, so for our word problems, you have a formula you're going to have to memorize. The only difference between growth and decay is a plus or a minus. Bless you. So this y equals a times 1 plus r to the t power is your formula. If it's a growth, then you're going to have a plus. If it's a decay, then you're going to have a minus. To me, that's very easy to distinguish. Okay? So your a in the formula, whether you have a growth or a decay, represents the same thing. A is your initial amount, whatever you start with. Your r is your rate of growth or your rate of decay. Okay? It's usually a percentage. You need to make sure you put it in decimal form. Okay, so if I gave you 25% increase, what is that as a decimal? 0.25, right? You put a decimal 2 places to the left. Okay, if I had 2.5%, move it 2 places to the left. I need a placeholder that's really 0.025. So be careful whenever you're converting it to a decimal. Okay? And then your t is just your time. Okay? Your t is like a general x. So you leave t in your formula until I specifically say estimate the value of, or estimate blah, blah, blah. Or then find blah, blah, blah. That's your very last step. Okay, but t stays t for your general equation. So, in 2000, the population of a city was about 1.04 million. During the next 14 years, the population increased by about 2.05%. Write a formula to model the increase in population in millions, state the growth factor, and estimate the city's population in 2008. So, is that a growth or a decay? Growth. Other than the fact that it says growth factor, what other word would tell me that it is a growth? Increase. Okay, so I know it's a growth. So then I know my formula is y equals a times 1 plus r to the t power. Okay, what's my a? What was my initial value? The 1.04 million. Okay, my formula is going to be in millions, so it's just going to be the 1.04. Okay, my r is 2.05%. That's my percent increase, but I need it as a decimal. So what is it as a decimal?
0.0205.
Very good. Okay, so it says state the growth factor. My growth factor is the full 1 plus r. Okay, so my growth factor is 1 plus 0.0205, which is just 1.0205. Okay, that's the entire thing that goes in the parentheses. So once I know that, my equation is just y equals my 1.04 times, I've already calculated the 1 plus r, that's 1.0205 to the t power. That's my formula for that population growth. We good with that? Alright, so now it says estimate the city's population in 2008. So I need to pay attention to what is my time. Is my time 2008? No, I'm starting in 2000. I want to know what it is in 2008. So what is that time really? 8. Alright, so I'm going to have y equals 1.04 times 1.0205 to the 8th power. Do not make this with the 8 your general formula. Your formula is with the t, and then you plug in the 8. Okay? A lot of people lose points for that, so don't lose points for that. All right, you can type that in your calculator, whichever one you want to do, the Inspire or the Scientific. Okay, I get that decimal. Now remember, I'm in millions. We're just going to round this to 2 decimal places. So this is going to be 1.22 million. Make sure you understand the format of your answer. If all you gave me was 1.22, you're telling me the population is 1.22, which makes no sense. Okay, so make sure you're relating it back to what your problem is saying. Okay? So then our next example talks about the value of a car. The value of a car in thousands of dollars can be approximated by the model y equals 31 times 0.92 to the t power, where t is the number of years since the car was new. Identify the initial value of the car, the decay factor, and the annual percent decrease. Then find the approximate value of the car after 14 years. So if it never said percent decrease, how could you tell that this is a decay? That's less than 1, right? If your base is greater than 1, it's a growth. If it's less than 1, it's a decay. All right, so identify the initial value. What's my initial value? $31, but it says the value of car in thousands. Do you think my car is really $31? It's $31,000. The decay factor, 0.92. Now the annual percent decrease, that would have been my R. Okay? Well, if I know my formula for a decay, it's y equals a times 1 minus r to the t power. Okay, well, my r is what makes it go above or below 1, right? So to find your r for a decay, all you have to do is 1 minus that growth factor, 0.92. That tells you how much it went below. Okay, that's going to give me 0.08, which as a decimal, my percent decrease as a percentage is going to be 8%. Because decimal to a percent, you go 2 places to the right. Okay, so if it was a growth, so say this last example, say all I was given was this. Well, how much above 1 was it? Well, just cover up your 1, and that's how much you added. Okay, so if it's a decay, you want to subtract it from 1. If it's a growth, just cover up the 1. That's how much you added to 1. It's very easy. Alright, so then find the approximate value of the car after 14 years. I'm just going to have my y equals 31 times 0.92 raised to the 14th. And I get 9 point that. But remember, you have to think realistically. My car is not $9.65. It's in thousands of dollars, right? Multiply that by 1,000. It's $9,646.98 after 14 years. Okay? Are we good with exponential growth and decay? All right.